Today we will focus on learning how to calculate displacement in 2 dimensions rather than 1. You will be able to recognize the 2D displacement problem if the diagram of the problem results in a 90-degree angle between your 2 arrows. This forces you to use the Pythagorean theorem to calculate your displacement. For example, we have an east, a west, and a north, and if you draw the diagram to this problem, it would look like this. Here's your 90-degree angle, and right here is your displacement. So today we have 2 sample problems that we will solve. Number 1, if Sally walks 5 kilometers east, then 3.7 kilometers west, and lastly 8.01 kilometers north, what is her total displacement? And 2, if Sally's 3.9 kilometers south of her house and ends up 4.8 kilometers west of her house, what is her displacement? For our first sample problem, I wrote out the givens. We first make sure to see that the kilometers match up. However, the directions do not match up. But we do know from experience that we can change this west to east by making the value negative. We then decided on the formula, and we went with delta D total equals delta D1 plus delta D2 plus delta D3 because of the word walks. Now we can substitute in our values. Now that we have the values into 2 directions, we can draw a diagram and justify that this is a 90-degree angle. With that, now we can use the Pythagorean theorem to find our delta D total. I'm going to substitute my values into the equation. After substituting in the values, we have to figure out the angle that the displacement took place in. So we use the formula tan theta equals opposite over adjacent. We rearrange it and we calculate this value. We round it to 1 decimal place. And since it's north of east, but it's over 90 degrees, so we have to, or over 45 degrees, so we have to subtract it from 90. So then we get this, which means we have to switch around the north and the east. So our overall angle is 9.2 degrees east of north. Now we come back over here and we have to figure out the significant digits. So since we're multiplying and there's 2 significant digits there, that means there's 2 significant digits here. And for this one there's 3, so we have 3 here. So now we have to keep the tenths column because we're adding. So we have that amount of significant digits. And again, multiplying, we need 3 significant digits. So overall, we have 8.11 kilometers, 9.2 degrees east of north. And that is our final answer. For sample number 2, I wrote out the givens. So first of all, we match up the kilometers again, but we notice that the south and the west do not match up. So we put our equation, delta D total equals D2 minus D1 because of the word is. However, we don't like subtraction when it comes to kinematics. We want to change this into delta D total equals D2 plus D1. So we take D1 and we change it to negative 3.9 kilometers north. So then we can substitute in our values. Now that we are using the addition of 2 values perpendicular to each other, we can justify that this is a 90 degrees angle and that we can use the Pythagorean theorem to calculate the delta displacement total. We will now use substitution. After substituting in the values, we get this as the answer. However, we have to find out the angle. So we use this formula, tan theta equals opposite over adjacent. After plugging in all of the numbers, we round to 1 decimal place and we get 39.1 degrees north of west. So now we have to do significant digits. Since we're multiplying, we keep 2. And over here we keep 2. Since we're adding, we keep the tens column. Multiplying again, we keep 2 significant digits. So we round this to 6.2 kilometers, 39.1 degrees north of west. And that is our final answer.